Hi everyone, welcome back to the Data Couple. Today we are continuing with our LeetCode75 series. We have already received amazing responses for our previous videos of this series. It really motivates us to continue this. So in previous videos, what we were doing is that we were tackling one problem in each video. But in today's video, I will be solving 4 problems at one go. So this video is going to be a little bit longer. So if you haven't subscribed already to the channel, please consider subscribing to the channel so that you don't miss out any future videos such as this. And yeah, so let's jump right in and solve the 4 problems that are listed in the string and array section of the LeetCode75 challenge. So here's our first problem. The first problem is reverse vowels of a string. So basically, this problem, it states that we are given a string and we need to reverse only the vowels in it. For example, if we have, for example, let's say we have hello as our input. So the E and O are the vowels in this word. So we need to swap these two vowels, keeping the consonants in the same position as in the original word. So the output becomes HOLLE. And if you look at this example that is given in here you can see that I, small e and capital A are the vowels that are present in this word. So the last vowel A and the first vowel I are swapped, and since these two are E, these are also swapped, but it doesn't feel like it got swapped, but it actually is swapped. So the main catch over here is that we need to swap the vowels only and not the consonants. The consonants should be fixed in their position, and we also have to take care of both the uppercase and the lowercase alphabets. So first step to solve this problem has to be to identify the vowels, right? So for that purpose, let us create a set of vowels which we can refer later on. So A, E, I, O, U and capital A, capital E, I, O, U. These are our vowels which we will be referring to. And we convert this into a list. Now what we will do is we will use a 2-pointer method. So one will start from the left and the other pointer will start from the right. And we move the pointers inwards until they meet. We would identify the vowels and we will swap them on the fly. So here's how we can do that. First we define the right and left pointer, that is equal to 0. That's the first point, left one, and the last would be the length of s minus 1. That would be the last index. So while left is less than right, if s of left is not in vowels, we will simply ignore and move forward. So we will move forward the left pointer. Elif s of right not in vowels, we will move the right pointer inwards, and we are continuously checking whether these are meeting or not. While they are not meeting, hence the last case that remains is that they are vowel. So if they are vowel, what we will do is we will swap the left and the right. S of right, comma, S of left, and that's how we do it. And of course we need to move the pointers inward. Now what we have done is we have converted this string into a list so that the iteration becomes easier. So now we need to return back as a string. Best way to do it is using this, and I think Okay, I think this will make sense now. Yeah, so the case is accepted, and let us submit. So we are basically scanning the string only once, so we get we go of n time complexity and it is accepted. And also because we are converting string to list, space complexity is also becoming big O of n. All right, so that's our first problem. So let us move into our next problem. All right, so this is our next problem. Our next problem is reverse words in a string. So here, the problem statement says that given an input string s, reverse the order of the words. A word is defined as a sequence of non-space characters. The words in s will be separated by at least one space. Return a string of the words in reverse order concatenated by a single space. Note that s may contain leading or trailing spaces or multiple spaces between two words. The returned string should only have a single space separating the words. Do not include any extra spaces. So basically what is happening in the input, if the input is the sky is blue, we have to reverse word by word. So the blue becomes the first word, is becomes the next word, sky becomes the next, and B becomes the last word. So this is how it is. And if there are any trailing spaces, this has to be removed while reversing the words. Right. So basically we are given a string with words separated by spaces. So what we can do is, first we should be splitting the strings by spaces. So let's say for example, so we have, let's say, words and we are given s. So we will split this by space. And now we have a list of words. Now we will reverse them using the reverse function. And finally we will return them by joining. And mind that we have used this space over here. Why have we used this space over here? Because we have to retain the spaces in between, but while we are doing the split, the extra spaces or the trailing spaces are removed. So I think that should be it. Yeah, this is accepted. Let us submit. So basically we are doing splitting and reversing, hence the time complexity for this becomes big O of n, and we are storing the words as a list, so that takes up big O of n for space complexity as well. So that's how we solve this problem. And let us move on to our third problem. The third problem here is the product of array except self. So this is a very interesting problem. It states that given an integer array nums, return an array answer such that answer of I is equal to the product of all the elements of nums except nums of I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs in big O of n time and without using the division operation. You can't use the division operation anyway, because if there's a 0 in between, so you can't use like a simple approach to solve this problem is okay. First let me explain the problem. So the problem states that you are given an array. You have to return a new array where each element is the product of all elements except itself. So for example, you have this 1, 2, 3 and 4. So the first one has to be the product of all the elements except this one, right? So in 0th index we have 1, so except 1 all the other elements has to be multiplied. So 2, 3, 6 times 4 becomes 24. For second case, like in the first index, you have index equals to I, you have the value 2. So this 2 cannot be in your end product. So your end product has to be 1 times 3 times 4, so that has to be 12. So a simple approach for this is to like multiply all the elements and then divide the product by the particular element of that index. But what if there's a 0? So if there's a 0, you can't divide by 0, right? So that's why this division operation is not accepted. So how we can do is that what we can do, we can create a prefix array. Though that prefix array would contain the product of all elements to the left of each index, right? And then we would create a suffix array. That suffix array would contain the product of all elements to the right of each index. This way we get the prefix and the suffix. So if we multiply the prefix and the suffix, we get the product of all the arrays except that particular element on that particular index. So let's say okay, so let's take the length of the nums. Okay, and let us create an resulting array. Let us define the prefix as 1. We will update this prefix while iterating. So for I in range of n, result of I equals to prefix. Okay, and the prefix has to be multiplied with the element. So this is how we do. And for this is our prefix part, and for the suffix part again we initiate it at 1 and then we iterate through the rest of the elements. So we start from the end and we iterate in a reverse order till that particular element. So that res of I times equal to suffix, and the suffix star equals to nums of I. This basically creates our return solution. So I think, yeah, that's it. Let's check. So we are doing 2 passes. So for each pass we get big O of n time complexity, and we are not taking into account of the output array. So the space complexity is big O of 1. Let us submit. And yeah, this problem is also solved. So let's move on to our 4th problem. This problem is increasing triplet subsequence. So given an integer array nums, return true if there exists a triple of indices I, j and k such that I less than j less than k and nums of I less than nums of j less than nums of k. If no such indices exist, return false. For example, if you have input as 1, 2, 3, 4, 5, the output will be true. Why? Because any triplet where I less than j less than k is valid. So basically there are 2 conditions. It has to be I less than j less than k, that has to be the first condition, and the elements on those indexes has to be in an increasing order, right? So that's why the name, increasing triplet subsequence. So basically we need to check if there exists a subsequence of length 3 such that nums of I is less than nums of j and it's less than nums of k with I less than j less than k. So the approach here would be that we don't need the exact triplet, right? We don't need the exact triplet. We just need to see whether there's a third bigger element in an increasing order or not, right? So first we will keep track of 2 variables. The first one would be the smallest number seen so far, and the second one would be the second smallest number after the first number, right? So if we ever find a number greater than the second, then the triplet exists, otherwise it doesn't. So it becomes very simple. So we will keep track of the first and second smallest elements. So let's say we initiate it at infinity. Now for n in nums, if n is less than equals to first, we assign first as n. Okay, else if n is less than equals to second, then we assign second as n. So we have got our first smallest and the second smallest. Else if we ever get any number that is bigger than these two, we are gonna return true. If it's not the case, then we would return false. It's doing everything in a single pass, hence it's big O of n from a time complexity point of view, and it's just 2 variables, so big O of 1 for space complexity. Let us run this code and check. Yeah, it is accepted. And let us submit to check. Yes, it is accepted. So yeah, that's it for today. We solved 4 LeetCode problems step by step: reverse vowels, reverse words, then product accept self, and this problem increasing triplet. So these are classic problems that cover two pointers, string manipulation, prefix and suffix arrays, and greedy tracking. By the way, what we did in the last problem is actually a greedy approach. So these are all very essential concepts for coding interviews. So if you found this helpful, make sure to hit the like button and subscribe for more LeetCode problem walkthroughs. And thanks for watching. See you.